Related rates video 3. So here's the condensed procedure. I had to draw the words real big so you could hopefully see them on the video, so I don't have a lot of space to put the work. Probably after we get started, I'll erase the words and push the work up so we can do our math after that. So let's see, we're going to plow into our first problem. So videos 1 and 2 are all the setup so that hopefully this makes a little bit of sense. So first thing to do is I'm going to draw it. All right, so just something simple so you get it. The main thing here is the pile the dirt's falling into. So it's going to fall on the ground. It's going to fall from a conveyor belt. I don't even really need to draw that. And it's going to form a cone-shaped pile. So draw a triangle, and instead of going straight across, you just make a little ellipse here. So there's my drawing. This is sand, and this pile is in the process of growing as the sand falls on it. All right, what variables make sense to use here? Well, height for sure. So I'm going to draw in this, and I'm going to call that h for height. Now, if I look at it, it doesn't really tell me too much more, except right here. It helps if you've taken some science classes. This is called dimensional analysis. Look at those units. Cubic feet per minute. Cubic feet, let's just talk about that. That is a volume measurement. How many cubic feet does that refrigerator hold? That's volume. So volume, I'm going to use V for volume. Really, I can't put it into the picture, but I know that I'm going to need volume, and it's the whole pile. Well, what do you think volume is calculated from? You go, I don't know. So we need the volume of a cone. If you don't know, Google it. I'm going to tell you what it is, but do not sit there and act like just because you don't know an equation, you can't do anything. You would use Google for anything else. Use it for your work as well. So if I Googled what is the volume of a cone, I would get this. Volume equals pi over 3r squared h. So see, there's my h. And I know I need volume. Guess what else I need in my picture? R for radius. R for radius. Okay, so I drew a picture and I put in some variables. In this case, there aren't really any constants to put in, but height and radius made sense here, so I put them in my picture. Now that I have a picture with some variables there, I'm going to start thinking about equations. Well, look, there's one of them. And by the way, this is our main equation. Talking about the volume of sand that's in this pile and how it's changing. Our secondary equation is this green underline information right here. So this we got to tinker with a little bit. So here's equation 1. Here comes my second one. Look, don't guess at it. Don't use your intuition. We are translating just like you go from Spanish to English. We're going to go from math to English. Diameter, let's call that capital D, is equals 3 times its height, 3h. Okay, see, I got my main equation, and I got this secondary equation. It's true, but it's not the main gist of the problem, but it's true. Now see how this uses R and this uses D? People mess this up so bad because they guess and use intuition. Be literal. I know there's another way to do this, but watch. The diameter is 2 radiuses. If the diameter is 3 pi or 3h, then 2 radius is 3h. And now it's very clear. I would actually write that like this. 3/2 h. That's how we want to write that. And that is going to be our secondary equation. Okay, well there's one other thing I skipped over, and that is, what am I even trying to find here? So let's tick this off. I don't know what that number is yet. Sand forms a cone pile, yes. Okay, this green part taken care of. And I haven't done this yet. So we have to deal with the 7 and the question. So, do you see the word rate? That's change in. Whenever you see rate or how fast, that is a D something number. Now look at these units. This is volume units over time units. See that? This is 7 cubic feet, that's volume, over minutes, time. So dV dt equals 7. Now, by the way, that's positive because it's growing 7 cubic feet per minute. If I was shoveling it off, right, then it might be minus 7. If I'm taking that volume away, then it's negative. If I'm adding to that volume, it's positive. So, see this right here? dV dt equals 7. Here's the words. The rate, the volume changes over time, is 7 cubic feet per minute. So this is a given. We're going to need that. Now let's jump to the question. How fast? D something. How fast, that's a rate of change, is the height of the pile growing? And it doesn't say compared to what. Over time is implied. How fast is the pile growing? When? Now here's the notation. This pile grows at a different rate depending on if like you're looking here or here or here. When the height is 4. What is the rate at which the height changes over time when the height is 4 feet high? That is our unknown. So here's the words. From the words, I drew a cone-shaped pile. I put an H and a R in there. I realized it's talking about volumes because of the units right there. And I looked up this equation. Then I knew I had to do something with the 7. See that word rate? It's a dead giveaway. It's derivative notation. And this is volume units over time. See, you got to pay attention to the units. If you don't like that, you got to deal with that. That's going to happen in problem after problem. You can't just shoo that away because it's not important. And finally, the question, how fast, dead giveaway, it's a derivative, is the height changing? And it's implied over time. As time progresses, how fast is the height changing? I don't know, that's my unknown. All right, so now we have to actually do some work. We've done steps 1, 2, and 3. I have my main equation, my secondary equation. Now I have to reduce them. So we have to do some math here, and I need some space. So what I'm going to do is I'm going to erase the words, and I'm going to pull all these boxed off things up to the top so we can focus in on the work. All right, I'll leave that picture down there. dV dt is 7. dH dt is what we're looking for when the height is 4. And our equations are V equals pi over 3 r squared h, and r equals 3 halves h. So that's all the pertinent information we extracted from the words. So how do I pull this all together and answer that question? So this is my main equation. It's got 1, 2, 3 variables. That is 1 too many. We've got to get that down to 2. So what do you think? We have V's, R's, and H's. How do you know which 2 you're supposed to have? The answer to that is you look at the givens and the question. See how we're given something about V? I think we're going to need to keep the V's. See how I want to know about the h's? I guess I should have used the lowercase h there. So it matches this. I guess we're going to need the h's. So I guess the r's are the ones that got to go. Well, what do I do? Just go like this? No, we do not just erase it. We use our secondary equation. See this r? See that r? We're going to substitute this in for r. And that reduces it, our main equation, down to two variables. Okay, so let's do that. So v is pi over 3 times 3 halves h squared times h, right? So this is going to be pi over 3 times 9/4 h squared times h. That's 3 halves squared h squared. This 3 cancels part of that 9. So I'm going to have 3 pi over 4 h cubed. So I've completed number 4. I reduced it down to two variables and streamlined it. Now here you might want to start plugging in numbers, or maybe you already wanted to. It said something about height is 4. If you plug in height is 4 now, you just can't go anywhere. You plug stuff in last. That is going to be hard to get used to. You have to plug stuff in last. So we have v equals h stuff. I need this derivative junk. That's how I know to take the derivative. I have v, I need dv dt. I have h, I need dh dt. So now we're going to do the derivative with respect to time. Now there is no t in the equation, so this is done implicitly. The derivative of v with respect to time looks like this. This is just a constant, albeit an ugly one. And the derivative of h to the third would be 3h squared, but this is with respect to t, so we need a dh dt kicker in the end there. See, this is implicit. Now I have the derivative. Next, I'm going to plug stuff in and solve. So what do I plug in? Look, dv dt, now that's showing up. Here's 3 pi over 4. 3h, oops. Now this is making sense. Where'd it go? When h is 4. So now is when I'm going to plug that in. Times 4 squared. And that is my unknown. So that's what I'm trying to figure out. So see how all the rest, I should be able to do this now. 7 is, and I'm going to plug this in a calculator. So I have, let's see, 3 times pi times 3 times 16 divided by 4. And now I'll divide by that, and I have dh dt is 7 over 113.10, and we'll just figure that out. 0.06. Now this was cubic feet per minute. The height would be changing in this many feet per minute. So it's going up 0.06 feet. If you're curious, that's only going up about 3/4 of an inch every minute, actually. I think I was saying seconds. So this is my answer. All that work to get it, that answer. So I'll stop it there. I'm going to give you a couple problems like this where I'm just going to change it slightly, but it's the same basic problem. And I want you to go through and try them. I'll have the solutions posted also in a separate file. Okay.